Welcome to Disruption Dialogues Podcast Season 2. Listen to the influential leaders and trailblazers from around the world as they share invaluable insights to navigating the fifth industrial revolution.
Hi, welcome everyone to another episode of Disruption Dialogues. This is Season 2. My name is Kaushik Paul, and I'm a Managing Director for Markets and Markets in the United States. Today, we have the pleasure of having Claudia Chandra with us. She's the Chief Product Officer at Rockwell Automation, and today we will be talking with Claudia on the area of data and AI strategy as it pertains to the industrial and manufacturing sector. So without further ado, welcome Claudia, and maybe you can do a brief introduction about yourself.
Thank you, Kaushik. Happy to be here, and good morning. So I am the Chief Product Officer of Data AI Edge Platform and Analytics at Rockwell Automation. Thank you for having me.
Great. Obviously, we're seeing a lot of change as it pertains to both data and data strategy, coupled with AI in the whole manufacturing sector. So wanted to maybe start off with your thoughts on, how do you feel data strategy can be effectively used for operational efficiencies in the space?
A data strategy enables you to scale the delivery of industrial applications and more advanced analytics with increasing optimization and automation. Usually without a data strategy, organizations will struggle with accessing and providing a data architecture to enable industrial analytics and applications. With a data strategy, it helps you to firstly provide easy access to a variety of data. Industrial applications usually need data from devices, controllers, operational systems on the plant floor, as well as IT data from ERP systems and others, as well as engineering and design data. A data strategy would standardize the way you access these different types of data. Then deliver that data with context, propagating context from devices up to the unit, machine, line, site, and enterprise level. A data strategy will also deliver tools and methods to process and store the data, transform, normalize, standardize, and aggregate the data with an architecture for data delivery to applications that reduces data movement and minimize costs. An important part of the data strategy is data governance. Data is useless if it is a poor quality or does not have context to decipher its meaning. Data governance provides those tools, processes, technologies, and people, as well as organization. Data governance assigns clear owners of data. It provides tools such as data catalogs, data quality monitoring and cleansing, data lineage, metadata management, data security, among others, to deliver trusted data. It also means defining processes to manage data to ensure it can be trusted. So having a data strategy is also the foundation to delivering more advanced analytics applications that enables automation and autonomous operations. Data provides the feedback loop required for autonomous operations, where corrective actions are automated to fix issues, reduce waste, and ensure machine and process designs deliver the expected results on the plant floor.
No, that's interesting to hear, Claudia. I have a quick question, though. A lot of what you said can be applied for data strategy across all industries and sectors. So, can you maybe specify a little bit more on how it could be, or how data strategy is applicable specifically for the industrial, say, for example, a manufacturing plant floor? How would that be different from, say, a typical IT data strategy?
Yeah, so certainly access to data, data quality, data governance, those are things that are common across the needs of data management across all industries. However, what is special or specific to industrial data is the variety of data and the need to bring that data from devices on the plant floor. So the fact that we need to harvest data that comes from the plant floor, from automation systems, those are controllers, devices, and historians. And then these automation systems also have different protocols to access it, quite different from IT systems. So these are legacy protocols also, such as Modbus, Profinet, among others. And of course, now OPC UA is the new standard for accessing data on the plant floor. And then in addition to the OT data, there's still also the need to integrate IT data from ERP as well as manufacturing systems. You know, manufacturing systems, you can say whether it's of IT or OT. I think some people will say it's IT systems, but others will say it's still OT data when we talk about manufacturing execution systems, MES, enterprise asset management systems, CMMS, which is computerized maintenance management system, QMS, and others, as well as the design data, such as data coming from CAD, CAM, and 2D and 3D drawings, PNID diagrams, and others. And then there's also a need to handle larger varieties of data in different formats. So we talk about these different data sources, but the formats of the data also varies, structured, unstructured, time series, logs, and events. We talk about design diagrams. There are also videos and others. And then data also needs to be delivered at different latencies, which is a lot more prevalent on the OT side, where time series data needs to be delivered in real time, streaming data in addition to batch. And there are also larger volumes of data that is involved. And then secondly, the need for context. So context is relatively specific to industrial data because data coming from devices usually lacks context. They just come in streams of time series data, but without the context of what those time series data mean, you can't make sense out of it. So this is what is specific also to industrial data. And then when there's large volume of data, the contextualization of this data needs to be done at scale, and so that it's not all manual. So this is especially important when dealing with large volumes of data. And then you also need to be able to define data models. There are industry-specific models such as asset models, asset hierarchies, and relating different types of data that is also specific to industrial. There are common data models such as ISA 95 for connecting enterprise to control systems and ISA 88 for batch process controls. And then you also need to be able to incorporate and link the physical models with digital models. So IT, data ops, and data management tools don't necessarily have those capabilities right out of the box. You can engineer these capabilities in them, but they're not native, right? So you need these additional data ops capabilities that are specific for managing industrial data, in addition to IT data when you're supporting industrial use cases.
No, that makes a lot of sense, Claudia. No, thanks for the clarification. Now let's, as we're talking about data, we hear from Rockwell and a lot of the articles that you're publishing, as well as a lot of our other clients in the industrial and manufacturing space, about the importance of integrating AI into their data strategy. I'm sure that's top of the mind, as far as your role's concerned. What are the challenges that you are seeing as far as doing that, marrying AI into the data strategy today as it stands?
Okay, so let's look at first the challenges around implementing the data strategy. So first, in implementing a data strategy, the challenge is connecting and harmonizing legacy sources of data or applications with new systems. These challenges have to do with the data captured in the old and new systems may be different. So there's a mismatch in the completeness of the data set, the format, and the means to access the data. Then the second is harmonizing and modifying business processes to work with and leverage the benefits of that data strategy. This typically requires multiple functions to assess, modify, and agree on a business process that works across the functions. The third is identifying owners of data sources, processes, and technologies that are part of the data strategy. A lot of times no clear owner exists because the systems and processes impact multiple functions, and each function needs to have a say in how these data sources, processes, and technologies are managed. And in implementing a data strategy, the approach needs to be phased with clear goals and milestones so that it's not a big monolithic effort that seems unsurmountable to achieve. And then for each phase, identify clear owners with clear RACI, who's responsible, accountable, consulted, and informed. The same is true in identifying owners of data sources, processes, and technologies. Now let's look at the challenges in integrating AI into operations. The first challenge is identifying people who has the domain knowledge to train the AI ML models. The second is identifying complementary data science skill sets within the organizations to deliver the tools, processes, and governance for managing and maintaining the AI applications. And it is also important here to define clear and realistic expectations when integrating AI. So just like in implementing a data strategy, this requires clear phases, goals, and milestones with clear ownership of the project and the identification of skill sets required for successful implementation. You also need the right tools and experts, consulting services who have done it before and therefore knows the methods and tools to enable successful deployment.
So that's very helpful, Claudia, for that explanation. You mentioned people and identifying the right set of people. And this is the whole ubiquitous argument that we are hearing across all sectors, all industries, is how do you really balance the whole human equation with AI technology? And what I'd love to hear your thoughts on, what are some of the key considerations that Rockwell has in place in order to achieve those balances?
Yeah, and in implementing AI, humans always need to be involved, and there is no way, especially in manufacturing processes, that the entire automation is done without some human review and approval. So here, because these industrial systems are mission critical, right? Where issues and downtime can cost millions of dollars. So AI technologies require a lot of training data and the right set of data to achieve the right accuracy of prediction. So there's trust that needs to be involved before you actually let it go. So plant operators usually and process engineers need to be comfortable with the automation. So there needs to be very much a review process and supervision, at least in the beginning, before enabling a true prescriptive and autonomous operations. Actually, there are very few where the closed loop automation are completely driving the entire manufacturing automation at this point without some sort of review process. So in addition, AI applications also need to be monitored for drift, because there's always going to be changes in the input, the model, there's concept drift, and this should trigger a retraining of the ML model so that diagnostics, predictions, and prescriptions from these AI applications are continuously refreshed from new data and continue to be accurate through continuous learning.
So Claudia, while we're addressing the whole balance of machine and human interaction, there's also the other issue of security and privacy as we're bringing AI into our operations. Would love to hear your thoughts on how Rockwell is addressing that aspect.
So, many industries, such as life sciences, semiconductor, and others, are still pretty conservative in terms of adopting cloud. So a lot of the controls, AI, ML systems that impact control systems are still deployed on premise or on the edge. And industrial and manufacturing companies also use air gap systems for their critical systems and the analytics applications that drive these critical systems, these automations of machines on the faculty floor, to isolate the systems and applications from external connections and potential attacks. But ultimately, these companies also need to apply similar security policies, tools, technologies, and processes on the plant floor as those that have been implemented in IT. So this includes implementing network protection, threat detection and response technologies, vulnerability assessments, and ensuring vulnerabilities are patched, the implementation of data security and protection tools such as data encryption at rest and in motion, strict access control with zero trust, data masking and anonymization to protect sensitive data. Industrial companies also are starting to look for more visibility and control of their security vulnerabilities, postures, and risk on the plant floor. And in the utilization of data for AI ML model training, where AI ML models are deployed across multiple industrial customers, and this is still very rare, by the way. Usually still, these AI ML models are trained for each customer. It's not reused across multiple customers, but where, potentially as we go in the future to support reuse of AI ML models and reuse and sharing of the data to train these AI ML models, vendors need to provide clear information on how collected data is used and the ability of customers to provide or withdraw consent of their data usage, and then request for information on what data has been collected and the removal of that data. So data subject requests, just like any other data that's collected and used for AI ML training across multiple customers. But industrial vendors are still at very early stage in this, because like I said, most of this AI ML models are trained for each customer. It's not necessarily reused across customers yet.
Claudia, thank you for giving us a lay of the land as far as data and AI is concerned on the manufacturing side and on the industrial side. But what would be really helpful to me and the viewers is if you can maybe bring in a live example of where AI and data has really been pivotal for the company in addressing a business problem.
Yeah, let's look at an example in the food and beverage industry where there's a lot of high-speed applications and where quality problems can go undetected. So these are lines that requires very continuous, process and manufacturing, and the impact of an undetected quality issue can be huge. So for example, if a recall occurs, it can be very expensive. When this type of event occurs, it's important for the operations team to find the source of the problem to prevent it from occurring again. Now, in order to perform a detailed root cause analysis, the team often needs access to accurate production data with timestamps for every batch and serial number. You need a data strategy and solution that can collect that data at high speeds and build an information model that contains the batch and serial numbers and the corresponding production data, such as current level, torque, and speed at each stage. This information model can be pushed to data storage or IT applications, either on-premise or in the cloud. With accurate production information, then IT applications can now enable both process engineers and data scientists to perform the RCA and prevent similar quality issues in the future. Now, once customers have access to industrial data, then they need to build reports and dashboards that enables them to continuously monitor the metrics that contribute to their KPIs. So a visualization tool that enables them to easily create trend analysis, reporting, and dashboards through easy drag and drop is also needed. And as customers graduate to more expanded analytics that require data across multiple systems and across OT and IT systems, such as MES, enterprise asset management, and ERP systems, relating data across the different systems and modeling these relationships are key problems that usually require a lot of effort due to the tribal knowledge and lack of context. Data quality due to missing data, lack of knowledge on how to interpret the data, and differing timescales, metrics, makes analytics challenging. Data contextualization for OT data is also key. And when you're dealing with large amounts of OT data, you need automated scaled contextualization based on pattern matching and AI ML. And by pulling data together from these multiple sources that customers need to get analytics across systems, that means you don't need to do this over and over again when you integrate it into a central location, so that once it's integrated, then multiple applications can go against it in that central data hub. So instead of having a point-to-point connection from the sources to the applications that need it, gathering all that data, bringing it together in a central location once, and enabling that data to be served up to multiple applications is also helpful in a lot of organizations. And for the most mature customers who are ready for more intelligent automation within their devices to control and optimize processes and detect anomalies in equipments and operations earlier to reduce downtime, then predictive and prescriptive analytics come into the picture. For pet food manufacturer, for example, a normal process for producing kibbles requires periodic manual grinding of the kibbles to test internal dryness, because sensing the external dryness alone usually underestimates the moisture content on the inside. Now, with an edge AI applications that provide self-sensing, it can learn to predict internal dryness based on external dryness and other factors. So this reduces the waste and eliminates the need to sample the kibbles periodically to grind it in order to test the internal moisture. So the learning here across customers is that defining and implementing a data strategy helps to scale the deployment of industrial and AI applications, whether it's on the edge or in the cloud, by connecting and bringing that required data together and standardizing the means to get at and consume the data. And then application management strategies to enable faster deployment and development of applications through application frameworks that includes API-enabled access and functionality, as well as low and no-code development, and the ability to orchestrate the deployment, monitoring, and management of applications at scale are also required, especially when you are deploying many applications, whether it's data connectors or edge AI applications that need to be deployed across multiple lines and multiple sites, and that needs to be done as a fleet. And it also makes it easier to maintain these applications over time when you need to update it.
That's very interesting, Claudia. You touched upon AI, ML, and analytics, both predictive and prescriptive. In your role as Chief Product Officer, can you maybe talk a little bit about how you are enabling your team to leverage data analytics to identify, say, market trends, customer preferences, potential areas of product innovation, et cetera?
So firstly, product telemetry is an important piece of understanding how customers are using the product and issues they encounter when using different features and functionality. And once you have the product telemetry, then you can perform basic to advanced analytics on the data to gather insights on how customers are using the product. Typical kinds of analysis to support product improvement is the path customers take to achieve a task or outcome, and identifying the steps where they drop off before completing their task. So that determines, the ease of use of completing the task and potentially how you can improve um, the workflow for these tasks. And then what errors did they encounter along the way? This analysis can also improve, the product itself as well as the customer journey within the product. Another improvement is providing in-context help and automated guidance, potentially to help users as they go through these task flows. So that's one of the things you can provide based on this analysis, in addition to any sort of improvement in the flow itself, so that it helps them to complete it. And then another typical analysis is the level of usage of different features to determine areas that the product team should invest more in. So certainly a lot more can be done to discover customer preferences and trends, but care should also be taken for companies to provide information about how they use the data that they collect from customers and to obtain customer consent, like I mentioned when I answered the security question and privacy question, so that we get the customer consent of using their data.
Very interesting to hear your thoughts on that, Claudia. This brings us to the end of our questions that we had for you. So any last thoughts from your side before we conclude this podcast?
The adoption of a data strategy as well as applying AI ML within the manufacturing and industrial automation space is still at a relatively early stage in maturity. I think there is still a lot of opportunities for advancements here, especially leveraging all of the data that comes from the factory floor, from the plant floor, for more advanced analytics beyond just trending, understanding how the plant operations track against KPIs, etc. There's a lot more that can be done in terms of going into more proactive improvements based on anomaly detection, predictive analytics, and also going to more automations and becoming more autonomous operations. There's still a lot of opportunities for leveraging both data and AI in that respect within industrial automation.
Thank you, Claudia. It was a wonderful learning experience for us, as I'm sure it was for the listeners, who again would love to thank for all the listeners listening in. I was in conversation with Claudia Chandra, who is the Chief Product Officer of Industrial Data, AI, and the Edge Platform and Analytics at Rockwell Automation. Thank you again, Claudia, for being here with us and sharing your time and your thoughts and valuable key learnings for us and our listeners. Really appreciate it.
Thank you, Kaushik. It's a pleasure.
Thank you.
Thanks for tuning in. If you want to know how you can navigate and thrive in this disruptive era, subscribe to Disruption Dialogues on your go-to podcast channels and stay tuned for more interesting episodes.